Okay, welcome to Homeline Study YouTube channel. I am Beino Vicent. Today's topic is current electricity, lesson 2. And to those who attended my lesson last week, we were looking at electric cells, and we looked at what we call primary cells in particular. And we said examples of primary cells include simple cell. We said we have a wet Lagrange cell. We also have what we call a dry Lagrange cell. So last week we looked at what we call a simple cell, and we said a simple cell consists of a zinc rod and a copper rod. We said you cannot rely on it because of the defects it has. And one of the defects that we looked at was polarization, which is simply the formation of hydrogen bubbles on the copper plate that insulates it from the electrolyte, hence blocking the circuit. Then we also looked at another defect, which is called local action, formation of tiny local cells around the zinc plate as a result of using impure zinc. We also looked at different methods or ways of how we can minimize those defects. Like for polarization, we said you can add what we call a depolarizing agent, manganese 4 oxide. Then we also said that you can brush regularly. Then for local action, we said you must use a pure zinc, or you can rub zinc, clean zinc, with a small globule of mercury. Now today's lesson, members, let us look at another example of a primary cell, which is called a wet Lagrange cell. A wet Lagrange cell is simply a modification of a simple cell. The only difference here is that, as you can see, in our wet Lagrange cell we shall have ammonium chloride. This ammonium chloride jelly is actually replacing the dilute sulfuric acid of a simple cell. We have a mixture of carbon and manganese 4 oxide. Now, of course, when I bring in the aspect of manganese 4 oxide, you know why we put it there. To eliminate the defect of polarization. So in here, all things are catered for. It is not like in a simple cell whereby you keep on adding manganese. Here, manganese 4 oxide is embedded within the system. Then we have carbon rod instead of copper rod, as you can see. Then we have zinc rod. Maybe the only difference which you should know here is that the depolarizing agent is already embedded in there. Okay? Which is not the case with simple cell. And then too, this one provides a relatively larger current compared to a simple cell. You can relatively rely on this, at least compared to a simple cell. So we are saying that when the current is being withdrawn from this cell, hydrogen bubbles tend to form along the carbon rod, which is positively charged. But because this carbon rod is surrounded by a mixture of manganese 4 oxide, the hydrogen bubbles will immediately be oxidized into water, meaning there will be no polarization. Another person can ask me, why do we have to bring in carbon? We bring in carbon so that we can reduce the internal resistance. There is always internal resistance. Maybe in the future we shall look at what we call internal resistance. So the resistance within the cell. So we bring in carbon so that it can reduce the internal resistance in order to supply stable current. So we have said the defect of polarization in here, it is simply minimized by using manganese 4 oxide, which oxidizes hydrogen gas to water. We are also saying that the wet cell cannot give a large current for a long time, by the way, because of a process of this depolarizing action. Because you add in manganese 4 oxide, there is always that action that takes place. It is this action which slows down the process. At the end of it all, it may not supply current for a very long period of time. So that is a disadvantage of using this wet Lagrange cell. Then, because this wet Lagrange cell could not serve the purpose, a very good purpose. You remember we are migrating from simple cell, now we have moved to wet cell. we introduced in what we call a dry cell. I know many of you know dry cells, or which we call a dry Lancalanche cell. So these dry cells, it's what we call amanda, I think in my language. I don't know what you call them in your language, but in my language is amanda radio. So we tiger heads, others are called, I've forgotten, Lasonic. So those are called Lasonic, Panasonic, those are dry cells. Those dry cells were brought in to solve the problems or the disadvantages of a wet cell. Ladies and gentlemen, boys and girls, let's look at what we call a dry Lancalanche cell or a dry cell. This is simply a modification of a wet cell. So, what does it consist? One, if you have ever seen a dry cell, it has that top part. That top part is called a blaster, and it is always the positive terminal. Then it has this downer part here. That part is called a zinc plate, or you can even call it a zinc can, and it is always negative. It has that black thing, it is a black rod in between. Actually, those who have ever opened it, you will find a black rod like this piece of chalk. Just imagine this piece of chalk, but black. And that rod is called carbon rod, and it is always positive. Then this carbon rod is surrounded by manganese 4 oxide. I think you now know why it is surrounded by manganese 4 oxide. To oxidize hydrogen bubbles into water. Then we also have ammonium chloride paste. In some other books you will find it as ammonium chloride jelly. I think if you have ever seen a dry cell, especially when it is getting used up, there is always that jelly that comes out, a sticky kind of jelly. That jelly is what we call ammonium chloride jelly. Now, we are saying that this carbon, and two, by the way, it is called a dry cell because it doesn't have a liquid. A wet cell has liquid, it has ammonium chloride, yes, it has ammonium chloride jelly, it has ammonium chloride, so which at times can power out. So here, we are having ammonium chloride paste, which is simply a sticky thing and a sticky jelly. And two, there is no liquid. And then lastly, it is portable. You can put it in your pocket and move away. So we are saying the carbon rod is surrounded by a mixture of manganese 4 oxide and carbon in order to oxidize hydrogen, form water. Then this ammonium chloride jelly, it will serve as an electrolyte. And it is prevented from drying by sealing the top of the cell with an insulator. I don't know whether you know the dry cell, there is that cut-off part, which is it blue or purple kind of? That part, its role is to prevent that ammonium chloride jelly from drying up. Then, like I told you, carbon in the mixture reduces the internal resistance of the cell and enables the cell to supply a stable current. Children, you must remember that even when you have not used the dry cell, even when the dry cell is in the shop and it has not been used, once you use it after a very long period of time, once you get it from the shop after a very long period of time, it will not work, or it may work for a few days and it goes, or it gets done. Why? Because even when you have not used the dry cell, it has a challenge of local action, which will reduce its EMF. We shall look at EMF, electromotive force, when we proceed in our subsequent lessons. Its electromotive force, which is 1.5, is reduced because of local action, even when the dry cell is still new. So someone who has shocked the dry cells today, and you just keep them and say, I will use them after 4 weeks. You will use them for 1 day and they get used up. Because their EMF goes on reducing because of local action. And again, we must agree that these dry cells, they supply low current. Therefore, you cannot rely them. Really, how many dry cells do you need to operate a TV? How many do you need to operate a woofer? How many do you need to run probably a generator, a fridge? How many? So because of this, and two, you cannot recharge them. You use them once and then you throw them away because they are primary cells. Because of all these disadvantages, from simple cell to wet cell, now to dry cell, we came up with what we call secondary cells. And these secondary cells, you can recharge them. Once they are used up, you can go and recharge them, you bring and you use them again. Like you see phone batteries. You cannot be worried that maybe my phone is running out, something of that kind. You know that immediately it runs down, you will go back, you charge, again you start afresh. But if this dry cell runs down, at times people just
a quick reminder, in a wet Lagrange cell, we have ammonium chloride solution, not ammonium chloride jelly. Ammonium chloride jelly is found in a dry cell. So the reason as to why we call a wet Lagrange cell wet, it is because of it having ammonium chloride solution which can pour out. Whereas a dry cell is called dry because it has no liquid. So there would be liquid or there would be ammonium chloride here. It is in form of a jelly or in form of a paste. So as I explained earlier, you know how it looks like. So therefore, the difference between a dry cell and a wet cell is that in a dry cell we have ammonium chloride solution, whereas in a dry cell we have ammonium chloride jelly.
Because the dry cell, you use it once, you throw it away. Even when some people put it on sunshine, I think you will find out why people put it on sunshine, and at times it works when they put it back. And two, they are not reliable. You cannot rely on dry cells. And three, how many dry cells do you need to operate a TV, to operate a woofer, to operate a very big radio? So we came up with what we call secondary cells. Secondary cells are those ones which can be recharged once they run down. You cannot be worried. Once it runs down, you simply run, put it in the power source and you recharge it. You don't throw it away. So, and like your phone batteries, you can never get worried of the phone batteries. What you do, after WhatsApping or doing whatever you want to do, and it starts bringing that red part of it, you run immediately and you recharge it. So these cells are called secondary cells. At times we call them accumulators, or we call them storage cells. They include, actually, they can be recharged. They can be recharged once it runs down, or once they run down by passing current in the opposite direction through them. They are also known as accumulators or storage cells. They include, we shall look at what we call solar cells, we shall look at what we call thermocouple, we shall look at lead acid accumulators. Lead acid accumulators, I mean our usual batteries, okay? Then we shall also look at what we call knife accumulators. But for purposes of this lesson, we shall dwell so much on lead acid accumulators. This is acid, and then knife accumulators. So we are going now to look at what we call lead acid accumulators.
Hey, welcome back. Let's now look at what we call lead acid accumulator. That is our usual battery, and as you can see, it has a positive plate, and that positive plate is called lead 4 oxide plate. It also has a negative plate, as you can see, and that negative plate here, this negative plate is called lead plate, and it is negative. Inside, this liquid is called dilute sulfuric acid. So we have said this is a negative plate, this one is a positive plate, and this is a screw cap for vent hole where you put distilled water or something of that kind. So we are not going into details of a lead acid accumulator, but we want to see how can you take good care? How can you maintain your battery to work for a very long period of time?
So let's look at care and maintenance of a lead acid accumulator. When I talk about lead acid accumulator, think about the battery. One, you should charge the battery regularly. That is one. Then two, you should never leave the battery in uncharged condition for a very long period of time. You should avoid overcharging and over discharging. Some of you, like if you are charging your batteries, the phone batteries, you want to charge, it is on charge from morning to morning, you are just destroying the battery. Then also two, some of you charge it when it is still having some power. For example, you charge your phones when they are on 80%. Every time you want it to be on charge. That is very bad. So then too, we are saying that you should maintain the acid level. How do you maintain the acid level? You always top it up using distilled water. Don't bring in boiled water. We are talking about distilled water. I think I've ever seen people taking their batteries and they add in water, distilled water. So we have already talked about this charging. Then we are also saying that the terminals of the accumulator, those positive, the negative, and even where you put the distilled water, those terminals, they should be kept clean so that current does not leak away. We are also saying you should avoid dropping or knocking the accumulator, throwing it on the ground. And by the way, it is very important when you are handling this battery, carry it or handle it with care. Don't just throw it on the ground or anywhere you find. Or don't even place it on soil or on just ground with no plywood or wood or piece of cloth. So that's why I'm saying that you avoid placing the accumulator on a bare floor. Because that coldness may affect it, or that dust may affect its functioning. Plus very many other maintenances that you need to look at in order to ensure or to maintain your accumulator in a very good working conditions. So in your groups, you are going to make notes on how you can charge and discharge the accumulator. You will research about it and you see how you can discharge it and how you can charge it. Now let's look at another type of accumulator which is also falls under secondary cell, which is called a knife accumulator, or what we call alkaline accumulators. We are saying it is made up of cadmium with a little iron to improve the efficiency of the negative plates. It is bulky and it is used to do at times heavy duties. These are the batteries they always put in the large ships, the batteries they always put in the electric cables. Then they are used in mining areas. They are not so common to you. They are called alkaline, they are not so common, but they are used at times as a substitute of lead acid accumulators. So now let us look at the advantages of knife accumulators over lead acid accumulators.
Okay, now one of the advantages of a knife accumulator or alkaline accumulator is that it doesn't require any special maintenance. But when it comes to lead accumulators, lead acid accumulators, already we have looked at the care and maintenance. These ones, they require special maintenance. Then knife accumulators, they may be left in uncharged condition for a very long period of time without even being damaged. In other words, they can be out of use for a very long period of time. Whereas the other side, the lead acid accumulators, they get damaged if left in uncharged condition for a very long period of time. Then the knife accumulators, they are long-lasting, they are durable, whereas lead acid accumulators, they are not so long-lasting. Then we are saying knife accumulators, they can withstand overcharging without getting damaged, But these ones, the lead acid accumulators, they can be damaged by overcharging. Then we are also saying that knife accumulators, they provide large currents without being damaged, whereas lead acid accumulators, they provide low currents. So you need to know those advantages of knife accumulators. Actually, knife accumulators are better than our usual batteries, because remember we have said these are used to work on those high operations. Think about ships, operation of ships, large ships, electric cables, and in mining areas. So therefore, that's why they are advantageous compared to lead acid. So let us end with the disadvantages of knife accumulators. Okay. Disadvantages of knife cells over lead acid cells. One is that alkaline cells are expensive compared to lead acid cells. And then two, alkaline cells have a low EMF. We shall look at EMF in our subsequent lessons, and have high internal resistance, which is not the case with lead acid accumulators. And then two, the components of alkaline cells are at times poisonous. And then lastly, they do not properly store charge. So members, thank you so much for following up our lesson. Endeavor to subscribe to our YouTube channel, Homeline Studying YouTube channel, to get more videos. Remember, I also thank those who managed to attend our Zoom lessons on Tuesday and Thursday. At least the number is growing. We are happy, and let's keep commenting. Let's keep questions coming in. My number is 0759746837. That is my WhatsApp number. Always inbox me in case there is something which is not clear. Let's keep the discussion on. I remain Beino Vicent. Shall see you next time.